Okay, ladies and gentlemen, this is the solution video for number 3, specifically part A. We'll do a separate video for each part of number 3 only because it requires several different pieces. So part A is sort of its own problem. It gives us information about the Welcher Adult Intelligence Test, which is composed of a number of subtests. In one subtest, the raw scores have a mean of 35 and a standard deviation of 6. Assuming that these raw scores form a normal distribution, what is the score a randomly selected adult would need to score in the top 20%? So what we do is we have to think to ourselves first, if we're in the top 20%, then that means that there is 80% of all data below us. Okay, that would mean we have 20% above us, that puts us in the top 20. That means there's 80% below. So what we're going to look for is what z-score is this that would separate the lower 80%. So we are going to go to the body of the chart and we're going to look up a score of at least 0.8000. So the chart I'm referring to is the one that I gave you on paper. I have it here on my iPad. We are going to look in here to find the value that is as close to 0.8 as possible. Now that value is found, it's 0.8023 is the best we can do, which is located in row, oh, I just lost it, here we go. It is located in row 0.8 and column 0.05, which means if we take those two values and we add them together, we get a z-score of 0.85. Now that doesn't really do us any good because the problem is not asking for a z-score, but we cannot do the problem without that z-score. So what we have to do is we have to plug that z-score into our equation, which says the z-score is the raw score minus the mean divided by the standard deviation, and use that to convert it back into a raw score. So we say 0.85 equals the x that we're going to solve for minus the mean from the problem, which was 35, divided by the standard deviation, which is 6. So to solve that equation, we are going to multiply both sides of the equation by 0.6. I'm sorry, by 6, not 0.6. We multiply both sides by 6. So times 6 times 6. That cancels the 6 on the right side and gives us 5.1 equals x minus 35. Then we add 35 to each side. Which gives us that x is 40.1. Now we do not have any way to figure out whether this test allows decimal answers, so that is the answer that we are going to provide. In order to get into the top 20%, and you should put this into words, you would say that a randomly selected adult would need to score at least a 40.1 on this test.